This video will explain when to use histograms and how to create and interpret a histogram. A histogram shows the distribution of a single numeric or integer variable. Similar to a bar plot, it tells you the number of times that something occurs. However, while a bar plot graphs a discrete categorical variable, a histogram can graph any numeric variable, integers or not. Moreover, a histogram plots the frequencies of observations in certain ranges or bins of values, thus showing where in the distribution an event occurs the most. For example, the central tendency of the distribution. In addition to revealing the central tendency, a histogram also shows whether the distribution is widespread or narrowly peaked, and whether the distribution is symmetric around the central tendency or skewed towards some outliers. These are the distinctional features of a histogram you ought to pay attention to. In this video example, you will learn how to create and interpret the distribution of the LSAT scores in a hypothetical review class of 26 students using a histogram. Just to be clear, the LSAT is the lower school admission test, in which scores range between 120 and 180 points. This is the data that we will use for the example. The first step in creating a histogram in an R Markdown document is to create an R code chunk. As before, click Code, Insert Chunk, and then you will see the following in your RMD file. Inside this code chunk, you will write the R code to produce the histogram. The second step is to create the variable for LSAT scores, which we will explain in the first comment line. Remember that it is a great habit to write a comment line above each line of code. It really does make your code look cleaner and much easier to read. Next, we will use the C function and the assignment symbol when creating a variable. This is the assignment symbol, this is C function, this is the name of the variable, LSAT scores. Unlike the bar plot, the histogram is based on one variable, and the focus is on the distribution of the values rather than individual observations. Thus, the values do not have to be in any specific order to match with those of another variable. The third step is to create a histogram plot for the variable using the hist function, which we explain in the next comment line. This is the hist function. Inside the parentheses of the hist function, list LSAT scores variable first, because this variable provides the scores of different students. Like in the previous sections and in the previous videos that accompany this textbook, the main option spells out the title of the plot, surrounded by the quotation marks. Distribution of scores in LSAT review class is the title of the plot. This completes the code chunk to create a histogram. The fourth step is to execute the R code by clicking an icon, R code chunk. Run R code chunk. This bar plot shows the frequency of LSAT scores in an LSAT review class. This bar graph is titled Distribution of Scores in LSAT review class. The x-axis has the LSAT scores from 120 to 180 with an interval of 10. The y-axis is labeled frequency, and the values on this axis range from 0 to 8 in intervals of 2. The final step is to interpret this histogram that we can do as follows. The histogram displays the distribution of LSAT scores in a class. To interpret the histogram, you should identify its peak, spread, and symmetry. In the figure, the most frequent LSAT scores are between 150 and 160. The spread of the distribution ranges between 120 and 180. The distribution is slightly skewed to the left, And it appears that more LSAT scores are clustered on the left side of the peak of the histogram. This video explained when to use histograms and how to create and interpret a histogram.